Hi guys, so this is our next unit on systems. So we're going to start by actually graphing linear systems. So hopefully we'll remember how to graph. I'll go through a couple examples here so you can see what's going to happen. So a system of linear equations consists of two or more linear equations. We're only going to focus on two. The solution is any point that satisfies all equations. So that would be the intersection point when we graph them. So here my m is technically 1 over 1. And my b is 2. So to plot that, we would go to 2 on the y-axis, and then my slope, up 1 over 1, up 1 over 1. Now you want to be fairly precise on these so that you can see the intersection point correctly. Okay, this one, my m is negative 1 over 1, and my b is 6. So start at your y-intercept of 6, go down 1, right 1, down 1, right 1, and we can see that they're going to intersect at this point right here. Your final answer is that as an ordered pair. So that would be 2, 4. That is your answer. Okay, let's look at another one. So here, my m is 1/2 and my b is negative 1. So go up 1 over 2, up 1 over 2. Like I said, you want to be pretty neat with these, otherwise you could get the point wrong. Here, my m is 3 over 1 and my b is 4. So go up 3, right 1, up 3, right 1. And hopefully you can see, like, they're clearly not going to intersect up here. So let's go the other direction. So let's go down 3, left 1, down 3, left 1. And we see that they're going to intersect right here, which is the ordered pair negative 2, negative 2. Okay. So now it asks the question, is 3/6 a solution to this system? So these two equations here. So to figure that out, we would have to plug 3/6 into both of them. So let's put, this is my x and this is my y. So put in 3 for x and 6 for y. And let's see, is this a true statement? Well, this is 6 plus 42, which does equal 48. Now it has to also work in the other one too. So let's put in, let's put in 3 for x, 6 for y, and does that equal 51? So 15 plus 18, that does not equal 51. So 3/6 is not a solution because it doesn't satisfy both equations. Same thing here, you could go through and plug in 2, 5 to see if it works in both. If it works in both, so if this had worked out, then you would say it is a solution. It has to work in both. Okay, I want to just do, let's focus on this this third one here. So notice they're not in slope-intercept form, so we have to solve them both for y. So let's subtract 4x to the other side, divide everything by a negative 6. So I have y equals, I'm going to reduce this. The negatives cancel and it becomes 2/3 x minus 2. I'm going to do the same thing for the other one. Subtract the 2x over, divide everything by 2. So I have y equals negative 1x plus 3. So here my m is 2/3 and my b is negative 2. Once they're solved for y, it's just like before. So, well, this is a tiny graph. So negative 2, go up 2, right 3, up 2, right 3. Okay, this one, my m is negative 1 and my b is 3. Down 1, right 1, down 1, right 1. And we can see that they intersect at this ordered pair, which is 3, 0. Okay, actually, I'm not going to do this top one, but I want to use the graph. So let's say y equals 2x plus 3 and y equals 2x minus 1. So here, my b is up at 3. My slope is 2 over 1. So up 2 over 1, up 2 over 1. Now this one, my b is at negative 1, and it has a, oh goodness, and it has a slope of up 2 over 1, up 2 over 1. So if you notice, and hopefully remember from last unit, these have the same slope. Okay, so that means that they're parallel. And if they're parallel, are they ever going to intersect? No. So these have no solution. Okay, they have the same slope but a different y-intercept. They're never going to intersect, so that would be a no solution. Okay, I will have office hours on Thursday if anybody has any questions or needs help on anything. I hope you're doing well.